Good morning everyone. Today I will be talking about the data structures. So data structure is the most fundamental and building block concept in computer science. And good knowledge of data structures is a must to design and develop efficient software systems. We deal with data all the time and how we store our data, how we organize our data and group that data together matters. Let's pick up some day-to-day examples where organizing data in a particular structure helps us. Our first example is a dictionary. A dictionary is organized as a sorted list of words. What if the words were not sorted in the increasing alphabetical order? It would be very impractical and impossible to search a single word among millions of words. Let's take another example of a city map. The data like positions of a landmark and road network connections, uh, all this data is organized in the form of geometries. We see the map data in the form of these geometries on a two-dimensional plane. What if there were no longitudes or latitudes and there were no such kind of a structure? It would be very difficult for us to route ourselves from one position to the other, like it would be for Vasco da Gama or Columbus. Let's take another example. Uh, we know that recently our CBS results were announced. So it makes most sense to organize and store the data, the information of the students who have qualified in the form of a tabular schema. What if these roll numbers were not arranged in the increasing order? It would be very difficult for us to find the information of a particular student. So now computers work with all kinds of data. Computers work with text, it works with audio, video, and pretty much any kind of data that we have on this planet. And yes, data coming from out of this planet is also managed by the computer. So how we store, organize, and group our data on a computer matters, because computers work with really large data, and even with the computational power of machines, if we do not use right kind of structures, uh, then our software systems will not be that much efficient. So let's look at the formal definition of a data structure. A data structure is a way to store and organize data in a computer system so that it can be used effectively. So let's understand what this definition is trying to see. A list is a very common kind of information we use in our day-to-day lives, and these are the very common operations that we perform. If there is a list on a paper, it is very easy for us to add something in that list, or search something from that list, or modify it. But if that list is stored in the computer's memory, then there are some algorithms, then there are some codings done so that these operations can be performed. Let's look at some of the data structures. Uh, the first kind of data structure we are looking at is array. An array is a collection of contiguous memory blocks like L1, L2, L3, L4, L5 and L6. These are the memory blocks. Let's suppose we want to store a list of names in an array. Then it will be stored in contiguous blocks, like Albert will be stored in L1, Babita will be stored in L2, Sia will be stored in L3, and in L4 Rahul will be stored. Uh, so if the computer wants to perform some operation like for example searching operation, like we want to search Rahul, the pointer is always pointing towards the first block of the array. Pointer is nothing but it denotes that this array starts from here, and processor starts looking from here and searches for Rahul in L1. If it finds it, it will display to the end user. Otherwise, it will move forward and look at the next memory location. It will move forward till the time it finds the desired result, and when it finds it, it will display it to the end user. And if it does not find it, then it will it will display some error uh, or some message that that this element does not exist in this list. So let's take an example that we want to perform an operation of insertion. As we see, all the names in this list are arranged in an alphabetical order. Let's suppose we want to insert a name Lavanya in this list. So we can determine that Lavanya will come between Sia and Rahul. So there are a number of ways in which Lavanya can be inserted between them, between these two names. One of them could be Rahul could be cut from L4 location and it could be pasted in L5, and Lavanya will be written to the previous location of Rahul, that is L4. So these operations are performed by certain algorithms, and on those algorithms code is written. So let's take a look at our next data structure, that is linked list. A linked list, in a linked list, the memory block is divided into two parts. The first part contains the data, and the second part contains the memory address of the next node. Like this node is containing the address of the next node. So let's suppose we want to insert this list of numbers in a linked list. 2 will be stored at 200, 200, 204, 214 and 224 are nothing but memory addresses. So 2 is stored at 200, 3 is stored at 204, 4 is stored at 214 and 5 is stored at 224. So what is done here, in the 200 memory address, in the first part 2 is stored and 204, the memory address of the next node is stored in this. Similarly, the 3 is stored in the 204 location, and 214, the address of the next node, is stored here. So these all nodes are connected with each other through a link. So that's why it is called a linked list. Let's look at our next data structure, that is tree data structure. There are many kinds of tree data structures. One of them is binary tree data structure. As the name suggests, there will be a parent node and two children will be there. Right child will always be greater than the parent node, and left child will always be smaller than the parent node. So if we want to insert these numbers in this sequence only, then what will happen? 25 will be inserted first, then 21. As it is smaller than 25, it will be inserted as the left node of 25. Then 30 is greater than 25, that's why it will come in the right side. 23 is smaller than 25 and it is greater than 21, so it will come as the right child of 21, and so on. This tree will be made. So this is a kind of data structure, and this is a way in which the memory of the computer is organized so that it can be used efficiently by the users. So I hope I was able to make you understand what the basic concept of data structure is. Thank you very much.